Okay, this originally started around the year 2000 as the resolution of microscopes was improving. We were interested in obtaining a field emission, SEM. So I knew we had to get something with a better coating capability. I was reading a lot of the publications from Japan, and they were doing some excellent work. I read the original paper by Tanaka describing the chemical vapor deposition of osmium, so I became interested in that. And then I became aware that there were companies in Japan that were producing the osmium coaters. And I looked around and I found the product from your company, and I was intrigued by the curved anode design. That seemed to be a very unique feature. And so that's how it all started. We became aware that you had produced a product, the Tennant20, and we were very intrigued by the fact that it's totally automated. And we've coated many, many samples with osmium, and we came to realize that the automation would be extremely helpful to us. And so that's why we went with Mewa Fosis.
We are a core facility, so we do research all across the university campus and also for independent businesses as well. I use the osmium coater a lot for powder samples because it is really good at getting into lots of those little tiny spaces which can be hard to make a sample conductive. Even if I'm not going particularly high magnification, sometimes it's better than the gold coating that we could also do.
So with this research, we were looking at mask material, like the one that I'm wearing right now. And we originally coated the sample with our high vacuum sputter coater that coats with iridium coating. And we found that our sample charged a lot with the iridium coating, and we weren't really able to get very great looking images. So eventually we retried the sample with the osmium coater, and we got much clearer results. The osmium really gets into all these little pockets and crevices of the sample to eliminate the charging that we were seeing.
So we really enjoy using this coater to look at things like bacteria. It does a very nice job coating bacteria samples. So this is a Streptococcus bacteria. And I also use it for many other samples, many biological samples, even when we're not looking at things at a high magnification. We like coating plant samples with this and trichomes, the surface of some leaves and things that people are studying. It works very well as far as coating in all the very small areas. It gets into the small areas where a sputter coating doesn't reach very well. So we really like that it makes it so conductive. It does a great job coating plant samples. This is the underneath side of a leaf, and you can see the vein going through, and you can see all the different trichomes on this particular sample. It does a very nice job of coating biological samples.
So this coater is very simple and easy to use. It's all automated. We can set the auto mode, and it has us load our samples and goes through the entire coating process without any work from us. Again, it's simple to use. It's very safe to use as well. Just been a really nice addition to the lab. I don't know that I have any requests yet. We haven't used it very much. I'm sorry. I don't know if I have a good answer for that.
We have a variety of coaters in our lab, and actually the osmium coater is probably my favorite coater or coating to put on samples, especially if they have very complex geometry. It just makes it so much easier to image when you don't have to battle all these charging artifacts and things, especially at higher magnifications. So I definitely recommend it for a lot of those kind of samples.